functions or not functions. Landon, I need you to turn around and face forward, please. Thank you. So today I'm telling you everything is a function. We're deciding if it's a linear function or if it's nonlinear. Right? So now we're breaking it down further into two other categories. The word linear means a straight line.
Can you slow down?
Yep.
I thought you said you needed to go fast. So
No, every time I get the shot.
I never said I needed that.
No, she said. When you weren't here. I think it over.
Listen, if I slow down, that's when you guys start talking, and then I can't, it takes twice as long to get you back. So that's why I go a little bit faster.
Vincent Spillman, get back to your seat.
There's two ways to decide if something is linear. Visually, which you would look at a graph. Right? Meaning whatever we write, whatever we actually put on the graph, which we're going to use our red pencil for, is it straight? Linear. Is it not straight? Nonlinear. Or you can look for a constant rate of change, which we will be looking at tables for that. Table of values.
I feel it's Jurassic Park.
So we're going to do some examples of graphs first. We have a continuous straight line, so that makes this linear.
I will use the pencil sharpener.
For the red one?
Yeah.
Nope. Do you need it sharpened?
This reminds me of like kindergarten when like the teacher had to like do everything because all the kids weren't smart enough to do anything. They didn't zip up their jackets. Like, teacher, can you tie my shoe? Oh wait, Liam still says that.
This next graph
What did you show a smiley face? I just typed like 2 months. Did you spell?
You need to get like a photo from an elementary school library.
Yeah.
this would be considered nonlinear because it zigzags, which means it's not continuous. Okay, so oftentimes students will say, but it's all these different straight lines. Correct, but it has to just be a continuous straight line. Because it increases and decreases, makes those zigzags, it disqualifies it. So it's nonlinear.
So it has to be exactly straight. So
It has to be-
have any curves or anything, no turns, no nothing.
Correct.
So the one you drew above is linear?
Right, because it says linear. This one would also be nonlinear
Max, you're so smart.
because it curves.
How about enough room. This is a first where you have more room than I do on the first page.
I don't know.
Uncool, dude. Uncool. Yeah, man.
I didn't mean it in a mean way. I mean like I'm just saying like I don't really space things out, but for some reason I kinda space things out.
After you take these.
Curves.
Why is number 2 stop?
What?
Number 2 stop.
This is how much money we're making.
Okay. All right, we're moving on. The next way, remember we said visually from a graph or looking for a constant rate of change, that's tables. So we have some more examples here.
Yeah. Is this on the back or new page?
New page.
Or you can do the back. Oh, that sounded like my that sounded like my dog was trying to throw up, but I can't get it out.
Stop.
Okay, so when I look at this table, we're not looking for a rule at this point. We're looking to see if the x's have their own constant rate of change and if the y's have their own constant rate of change.
What am I doing?
If they each have their own constant rate of change, then it's considered linear. So what is happening between each x value? What is happening?
They're going up.
Minus 2,
Oh wait, no,
They're going down.
negative. I'm so.
right? So the x's have their own constant rate of change, so we're halfway there. What's happening to the y's?
Minus 4. No.
Oh, this should be minus 9 here. Sorry. This should be a minus 9.
Oh, man.
There we go. That'll make more sense
Oh,
now.
'cause I think.
What's happening here now between these?
Changes this.
Minus 6. So this is considered linear.
Lit off.
Constant rates of change.
Lit off. Well, that's gonna be hard.
For x and y values. Now notice they don't have the same constant rate of change, they just both have one. Okay, so these don't have to match. These 2's and these 6's do not have to match. They just need to have their very own constant rate of change. Right, and that happens by adding or subtracting to get to the next value. This does have a rule though, if you wanted to come up with a rule. What would the rule be to get from my x values to my y values? Emma?
Times by 3.
Yeah, y equals 3x. Which, for those of you that are like, how did you get that 3? Negative 6 divided by negative 2 is
3x.
3. Yeah, but we're not super concerned with slope at this point. Okay, next example. We're going to do a horizontal graph, or excuse me, a horizontal table.
I always get horizontal and
I think
vertical.
of horizontal like the horizon.
That's smart. Thank you. And then vertical could be like.
No, it's not.
No, it's like where you can see where the like sky meets the ground, that's the horizon. Like in your vision, where you can see as far as you can, where the sky and the ground seem to meet, that's the horizon.
Did you just say? I feel like it's just the ground.
The way I remember horizontal is if you write it out. Well, the
Well, every
Z's,
word is horizontal.
the Z's have two horizontal. The Z has two horizontal lines.
But so does the T has one. The what?
Okay, but that's just how, I'm just telling you how I remember the word horizontal.
Yeah.
Okay, so let's figure out if we have constant rates of change here. What's happening between each x value?
Oh, they're getting added by 5.
Sure. And then how about the y values?
Huh.
Yeah. So it doesn't happen often, but sometimes the rates of change will match, but that's not a requirement.
I mean, it's like linear.
So this is linear.
Linear. This should be completely silent.
And then our last one,
We're almost at lunch.
Oh my god.
I'm
so hungry.
What's for lunch?
Hot dogs are
Except the hot dogs, their buns are bad, but the hot dogs are decent.
They look like home. Yeah, they're like right from the package.
professional.
Cuisine.
okay, so what is my rate of change for my x's? What's happening here?
On the one on the
Caitlin?
right.
2.
Plus 2 for all of them. How about my y's? What's happening here?
4, 6, 8.
They're every time. So I don't. Okay.
Add 4.
Add 4, but then I add 12,
So
and then
one-
I add.
So the one on the right is not linear, which means the whole thing is not linear.
This is not a constant rate of change, so that makes it nonlinear.
So both of them then become.
Wait, what does that say at the top?
Nonlinear.
And then with the dash?
The
Oh, oh.
I did.
Yeah, that was better.
y values do not have a constant rate. Okay. Nope. So that makes it no bueno.
No.
Boom, chaka, laka, chaka, chaka,